this video, we're going to take a quick look at problem 107. The fireman wishes to direct the flow of water from his hose at point A to the fire at point B, which is 20 feet below point A and 35 feet away in the horizontal direction. We want to determine two possible angles at which this can be done. Water flows from the hose with a speed of 80 feet per second. What we need to recognize here is that one of those angles is going to be below the horizontal and the other angle is going to be above the horizontal. Once we have determined that, it's fairly easy to draw the vector diagrams for this situation. Remember, the vector diagram is coming from the equation delta S is equal to VA delta T plus 1/2 the acceleration times delta T squared. In this case, we are looking at an angle above the horizontal, and we're going to look at VA times delta T times the cosine of the angle. That must be equal to 35, and the initial speed is 80, so that gives us equation 1 here. And then doing VA times delta T times sine of theta, which is 80 times delta T times sine theta, that's equal to this distance here, which is 1/2 the acceleration times delta T squared minus 20, where 1/2 of the acceleration is 16.1. At this point, we have two equations and two unknowns, so I'm going to stop here. It's possible to solve it for the angle. I'm not going to do it. It is kind of tedious. I don't necessarily need you to sit down and go through it on your own, but if you want to know what the solution is, you can use a computer to solve for theta. Okay, the other angle is below the horizontal, so this vector going from point A to point B is VA times delta T. This angle here is theta, and this is my 1/2 acceleration times delta T squared vector. When I add that with VA times delta T, I get delta S going from here to here. We're going to look at this right triangle here. So the base is 35, so 80 times delta T times cosine of theta is 35. And the sine of theta times VA delta T is this little piece here, which is this full distance of 20 minus this piece, which is 1/2 the acceleration, so 16.1 times delta T squared. So that's that little piece, which is 80 times delta T times the sine of the angle. Again, we have two equations, two unknowns. I don't really feel like we need to go through and solve for theta, and if you want to know what the solution is, just like for this one, you can plug it into a computer. And that concludes 107.